All right, afternoon, everyone. Thanks for coming out. I am Eli Elliott, and here to talk about how Gap uses OpenStack and Cloud Foundry. I'll be focusing mostly on that how, and not as much on the retail experience, but I'll welcome questions after. I was originally going to co-present, so I hope you'll bear with me on some of these slides, which I wasn't originally going to speak to. So, what sets us apart? This is the gap in general, right? For me, adopting best technology and practices is what it's all about. It's interesting to work for a retail company that has its headquarters very close to Silicon Valley. It gives me a unique opportunity to maybe do things that a lot of retail companies wouldn't try, including open source technologies like OpenStack and Cloud Foundry. So today, I want to go over the platform choice, why we chose OpenStack, and this is going to be a little bit of historical information because we started using OpenStack back in 2013. Also, why we chose Cloud Foundry. And then I'll talk about lessons we've learned over this adventure, and summary, and then Q&A. So let's get right into it. Our platform choice. We were a VMware shop for virtualization exclusively, and there were challenges with that, and they're much less now, but they do, to a certain extent, still exist. And those challenges at that time were that we were a blocker, right? The technology folks were a blocker. You had to engage us to get your VMs. And if we were busy, it might be a week or two before you got your VMs. And that's not a great way for folks to work. And so when we started looking at OpenStack, primarily it was for the quick spin up of VMs. And we pretty much saw immediately that we went from days or weeks to realistically minutes, but for a whole environment, let's say hours. So to drive the adoption of OpenStack, we piloted it with a single team. That single team was our e-commerce platform team. And the reduced, the isolation pipeline, the testing that goes into the site before it goes live was greatly reduced by being able to just spin up a VM from the pipeline, right? Spin up a VM from the pipeline, put out the new code, test it extensively, tear it down. I'm not saying anything that anyone hasn't heard before. But it was a big difference in the paradigm at Gap. And so because of the success of this pilot and the extreme reduction of the business time, OpenStack now runs almost everything. We still have VM, we still have bare metal, but when it comes to new applications, to our pipelines, to Cloud Foundry, we're running everything on OpenStack. So let's talk about Cloud Foundry and why we chose it over maybe a container platform. Now, keep in mind this was a few years ago, so containers were not quite as known. So we deemed right away that Kubernetes was a little bit too new, and we needed to implement something solid right away that we could start using. So it needed to be robust enough for our entire online business, and it needed to include load balancing, scaling, and service integration. And these were key. It had to do all of it. So let's go back to OpenStack now. We have, at the time, Cloud Foundry, a product that, at the time, we were told should really run on VMware. And we didn't really want to do that. We felt like our OpenStack Cloud was secure enough and was robust enough to be the platform for Cloud Foundry. So we began to talk about What features do we need in the cloud for Cloud Foundry, right? And here's the answer we came up with. We needed object storage, we needed block storage, we needed a network that could scale with us and could change, and we needed, of course, some good compute. So the architectural concerns that we had to deal with were that OpenStack doesn't provide HA to compute instances like vMotion does, right? So how do we plan around that lack? Also, our OpenStack scheduler is pretty much round robin, right? I mean, it does pick the least loaded system, but it's not really rack aware. It's not switch aware. We didn't want to end up with too much on a single switch, too much in a single rack if we lose the rack. So we wanted to plan around that. Also, Iscuzzy traffic could cause a major dent in our total network bandwidth, right? We didn't want to end up bottlenecking ourselves because of our sender storage. And then lastly, Cloud Foundry instances needed a large memory footprint. In general, my rule of thumb in OpenStack is I don't want VMs with a large memory footprint. 16 gig is about the max I'll give a project team. So 16 gig is obviously too small for Cloud Foundry, but it's just about the right size for what we call our extra large t-shirt size. So in the design and planning, I wanted to create aggregates that defined these safe compute zones, right? So that if there was an outage in OpenStack, Cloud Foundry could handle it. So also, since the OpenStack scheduler isn't rack aware or switch aware, I wanted to make sure that the aggregates we created spanned basically the data center, right? So that if there was an end of row switch and we lost, rack A, the end of row switches, if we lost that end of row switch, the end of row switches for row B, row C were contained in the aggregate so you didn't lose everything, right? Might make more sense here. Physical separation, right? We have a rack in row 1, in row 2, in row 3. They all have different power. They all have different switches. Maybe not different core switches, but at least end of row switches. And so we separate each of those into their own aggregate. If we lose any one aggregate, we still have 2/3 of the compute platform available for Cloud Foundry, and Cloud Foundry can recover at that level. And then the Iscuzzy. So it was decided, we went back and forth, and one of the things I wanted out of Iscuzzy was its own network. And not only did I want it on its own network, but I wanted that network to not be routable. I wanted it to just be an OpenStack network. That way, anything that went wrong in it, we knew was our fault, right? We knew it was something we needed to investigate, we needed to work from the OpenStack perspective. I didn't want any confusion to that. So we bought dedicated switches and additional network cards, and that's exactly what we did. But there were additional costs in those switches and network cards. And also, we lost rack space, so there's less compute per rack. Another important consideration for us was, in these additional network cards, if we lose one network card, I want to have both the Iscuzzy network and the regular network up and available. So we needed to be able to create HA bonds across the network card. And also, since some of these systems could be very busy, we wanted to make sure both Iscuzzy and VXLAN was offloaded to the card instead of the kernel doing the work. So this slide is talking about the way I designed OpenStack for compute workloads. Okay, so hypervisors give 2 gig of memory per vCPU. And so by strictly regulating this ratio, we eliminated a lot of memory issues, especially any traffic across the NUMA bus, which was more of a concern in the past than it is now. But if you're familiar with the NUMA bus, it's a way to address memory on the other CPU, and it's very restrictive. very slow. So we definitely want the CPU your workload is on to be addressing its own memory, right? But the CF instances needed a large memory footprint, and, well, I'm still talking about the architectural background. All right, so also, in the retail world, we have a very busy weekend, right? Thanksgiving weekend for us can make or break us. So, as a standard rule, I didn't allow CPU oversubscription past 1.5 to 1. And this assured that even when we were being crushed on a Black Friday, we didn't have to worry about a lot of I/O contention amongst the different VMs. So the other thing we never do is we never oversubscribe memory. So when we buy a system and we figure out how many cores there are and how many vCPUs that turns into based on our oversubscription, we make sure we have enough memory to cover that 2 gig per vCPU, because that's what our t-shirt sizes use, and a little overhead, right, for the system. So when we were looking at creating the Diego cells, we kind of determined that we were going to go with a large memory footprint, and we were going to go with 32 gig. And there would be smaller instances, but the general size would be a 32 gig memory footprint. So that for us, 1.5 to 1 in Cloud Foundry was way too conservative. So we did some testing, and we determined that 6 to 1 was really good. It gave us performance under high load, and it let us really scale Cloud Foundry. So, but that was another additional cost, because before, where we had 2 gigs of memory, we now need 8 gigs of memory. So on a 40-core hypervisor, that's half a terabyte of memory. So back into Cloud Foundry. When we're talking about Cloud Foundry and design and planning of the microservices, we need, there are a few things. This was the portion that my counterpart was going to talk about. So let's see if I can get through the notes here. Microservices, CI/CD best practices, cloud native design. These are things that we had to educate our developers on, right? 12-factor app design was a big thing. Using microservices for any single task, and then string those microservices together to create app functionality, right? So when we went to determine requirements for Cloud Foundry, it was a huge team that got together to talk about it, right? Multidisciplinary, because we needed a holistic solution. We needed CI/CD built in. We needed the business processes built in. We needed to figure out how we were going to educate. So some of the considerations are, PCF is very opinionated, right? It requires deployments to occur in a specific way, right? Aligning with 12-factor apps, right? Logs are an example, right? App logs, they don't stay in the app. They don't stay in Cloud Foundry. They're shot out, right? We use Splunk. And so that function separation is critical, right? So we needed to prevent bad design patterns, right? From the developers, we had to always ask, yeah, you can do that, but should you? Let's think about that, right? As an example, developers wanted to use persistent NFS stores, right, inside of Cloud Foundry. And it's not a good design. We don't want to store anything inside of Cloud Foundry, especially if it's spread out, we also didn't want session persistence. So, call another service, use a blob, use SQL, right? Just separate out these functions. As an example, if you write files, and we did have folks do this, write files inside of Cloud Foundry, and the app crashes, and that droplet's redeployed, that data's not there anymore, right? Your app is broken. So, yeah, can you? You can, but should you, right? And service offerings can be very challenging to manage. As an example, RabbitMQ, right? Everybody wants RabbitMQ. Managing a RabbitMQ inside of Cloud Foundry is certainly possible. but it's not going to be tuned for your specific use case. It's not going to be tuned for your application. We're going to tune it for a general use case. So do we want to do that? Do we want to provide these services, or do we want to ask you to provide the services as a developer, right? Do we want that app separation? You throw up your RabbitMQ cluster on OpenStack, right, which we have cookbooks that can do easily, and call it from your Cloud Foundry deployment, right? Also, shared services are a challenge to upgrade and maintain. Can the app handle a service restart? Is it robust enough? In a lot of cases, the answer is no, right? Do developers think that their underlying shared service is going to go away? They probably don't. So so we've pulled most of those shared service offerings outside of PCF. And we asked them to use IaaS to build and tune for their app these pieces. Tune it your way, consume it the way you want. So, on to lessons learned. And I know I'm moving fairly quickly, but more time for questions. The OpenStack, the lessons we learned were a few. Large memory footprint VMs, these 32 gigabyte VMs, they can have problems if you have KSM enabled. So KSM will basically run a dedupe on your memory. And that's great for saving on memory, but we made sure up front to buy enough memory. So we don't need it. We found it running, and where we found it running, we found CPU softlock errors on these large VMs. And this happened not just inside of PCF. We saw the same thing on large RabbitMQ IaaS, and other big VMs. So that was something, that was a challenge. Also, when we implemented, I wanted to go with Ceph. I really did. Really wanted to go with Ceph. Couldn't do it. So we ended up going with Swift, and Swift is not fully S3 API compliant. There's some projects in the works that are giving us some, proxy FS and things like that might get us there, but we're not quite there yet. So we couldn't implement Ceph. We needed a blob store that was S3 compliant, so we ended up using Ryak. The other lesson was with Cinder. We already talked about me creating a special Iscuzzy network, but that Iscuzzy network is only as good as our configuration. And in some places, our configuration wasn't great. We had a few fall downs in the automation and deployment of multipath D. So in most places, multipath was fine, and in some places it wasn't. And that kind of problem isn't very visible. So we found working with the storage team was critical, because they could tell us when we didn't have multipath enabled, and they could tell us which MAC address didn't have multipath. And when they go to do their upgrades, that's one of the first things they check. Is everything multipathed? Is everything going to be okay if I take this controller down to upgrade the firmware, or what? So close partnership with your storage team, if it's a separate team, I would highly recommend. Moving on to Cloud Foundry, the object store can cause downtime, right, for app deployments, because that's where the droplets are. So if you have a problem with your app while the object store is down, you're not going to get it redeployed. And we chose Ryak for its S3 compatibility. Right now, a lot more options exist, and we probably would choose a different object store. So something to keep in mind if you're looking at this. So service tile, availability, scalability, customization. This is going back to talking about the previous slide where I talked about creating your services in IaaS and customizing it for your app and consuming it rather than having a shared service. Definitely, in our case, the preferred way to go, because maintenance on those shared services just cause impact that are kind of out of scope with the importance of the service. And then, user education User education is very important. App restarts, if you're scaled correctly, an app restart isn't a downtime, and getting a 503 isn't the end of the world, right? If you hit refresh, your app's going to be there the next time, and that's something that outside of Cloud Foundry, you know, a 503 would be the end of the world. It would mean your app is down. So we need to educate the users about that. We needed to educate them that because of the shared services possibly getting maintained, upgraded, brought down, they needed to make their apps more resilient, and that it is a developer responsibility to make the apps resilient. And then lastly, and this one is equal, it's the same for Cloud Foundry as it is for OpenStack. The CI/CD pipeline process can kind of be a black box to developers. And so we all the time, even now, will get messages from a developer, you know, my call Nova failed and couldn't build my VMs, or my call PCF failed, couldn't build my app. And when we look at the error, just because it's called call Nova in the pipeline doesn't mean it's actually a Nova problem. It could be a network problem where it just couldn't reach Keystone, or a password problem because it couldn't authenticate, right? But teaching them about the CI/CD process is critical to making, you know, faster turnover of problems and having them being able to troubleshoot their own problems. So that's another part of the education we've been working on. And so that is pretty much the lessons learned, right? We planned ahead, we tried to design for failure, and we partner not just with dev teams, but with other operational teams, with the storage teams, with as many folks as we can, and then we educate. So if there are any questions, please come to the mics, and I'm happy to answer them. They won't be able to hear you on the recording if you don't use the mic.
So you mentioned that you have separate network for storage. What storage do you use?
It varies, but in all cases, we're currently using solid state, you know, big vendor, EMC or Pure storage arrays.
And what was the problem with Ceph that you couldn't make it?
At the time, we're partnered very closely with Rackspace, and we use their distribution. At the time, they did not have support for Ceph object storage.
So in terms of operationalizing the solution, so what kind of challenges or lessons learned did you have on the people and process like aspect of the solution?
That's a good question. I'm not sure I fully understand the question. Can you?
Yeah, like in terms of, so it was a VMware shop, right? So like you had a lot of like expertise in terms of managing the VMware solution. And now like OpenStack and Cloud Foundry was like a new thing in there. Mm-hmm. And back when you deployed it, I'm sure it was not as mature as it is now, right? So in terms of like up-leveling the skill set or training, being able to manage the solution, like how challenging that was, and what did you have to change in terms of your processes as well as like having new roles and putting people into those roles?
Sure. Yeah, I say there were significant challenges with that, which we mitigated by partnering with Rackspace. So using their distribution and using them as the first level of support was very helpful in our adoption. We built up the expertise over time, but Rackspace gave us that flexibility to have the time to build up the expertise. And also, as a retail company, I can't take half my week to, you know, help develop a new enhancement for an open source project, right? So another nice part of dealing with a company like Rackspace that does, let me get this back here, that does contribute to the code base, is that we were able to come to, you know, like with the Ceph issue, we're able to come to them and tell them what we really need out of the product and actually able to see them start contributing to that code, which was great.
Okay, thank you.
Hi.
Hey.
Well, you said you had to change Swift because it was not full S3 API compliant. Which part of the API you needed at that time? What was the most important of the API?
So my counterpart, Ty, will be able to answer that off the top of his head. I would have to look it up. At the time, and I think even now, our Swift implementation only has the very basic S3 compatibility. So I don't know what advanced portions Cloud Foundry uses, but I think even now we can't switch over to Swift.
Oh, good. Thanks.
Hi.
Hey.
In the current landscape, are you continuing to use Cloud Foundry, or do you look into other options?
We are. As a matter of fact, we're expanding Cloud Foundry and adding more foundations and adding Cloud Foundry to public cloud. We do plan to use containers, but for right now, we've been very effective with Cloud Foundry. So,
Do you have any timeline on making a switch, or is it just something that you're looking into?
I would not anticipate us actually making a switch. My guess would be we would do both and let folks choose which works best for their app.
How do you inform and educate your developers at that point when there's something else that they have to add into their toolbox when they're learning maybe Kubernetes, for example?
So we have a bunch of folks that's really all they do. And building out the guidelines and the flow charts for helping folks choose the right technology is a very important part of what the architecture team does at Gap. And I think they're pretty good at it. So.
All right, thank you.
Hiya. Could you talk a little bit about sort of like Gap's physical infrastructure? Like how many data centers do you have? Where are they sort of like located? Are they colocation or in-house?
So we have a mixture. We do own a data center. We also co-locate at a data center, and then we have a data center at our HQ. I do have clouds in all three of those locations. Yeah, we're a mixed bag, and we use Azure as well. So.
Okay, thank you.
On the networking side, do you do anything like Layer 3, Calico, BGP, or anything like that to kind of flatten the network, reduce the hops between the application, web stack, allow you to sprinkle everything across the rack, support failure domains, and all that fun stuff?
Well, the short answer is no. We don't. The longer answer is we do some of that for different functions. Inside my domain, inside of OpenStack and Cloud Foundry, we don't right now. The SDN is primarily just Neutron and just contained inside the private clouds. We're open to doing more, and we partner pretty closely with the network team, and we have POCs in the air. But right now, we haven't found a driving need for it.
Okay.
We do. We use Pivotal. Yeah. Same thing as with Rackspace, right? Having a partner was important. So.
Hi, I have a question about how you actually build your machines. You mentioned that you do have your own data center. So let's say you stick a machine in there. What do you do next? How do you build it?
How do we build it? That also varies. So I've used Canonical's bare metal, and I use that for my test cluster. For production right now, we're using Cobbler, which has been established, and we've been using it for a long time, and it works pretty well. From the firmware side, we use the provider tools. So my clouds are mostly Dell, so we do have Dell OME. And so we can kind of automate and maintain firmware.
Cool, thank you.
More questions. So if you were to start fresh now, right, so what would you do differently?
What would I do differently? I would be more aggressive. You know, I do feel like to a certain extent we kind of dabbled, you know, put our toes in, felt what the temperature was like. I would like to see a much more automated data center. To what he was saying, I'd love to put a rack at a time in. I'd like to have Redfish to manage that whole rack and all the firmware on that rack. I'd like to have Ironic to push the OS to everything. And I'd like to just literally be able to say, add that rack, and it's done.
Cool. Thank you.
All right. Well, you guys get a few minutes back. I'm glad I talked so fast.